So this problem says write a quadratic equation. It'll be in standard form. So that's ax squared plus bx plus c equals 0, in the variable x having the given numbers as solutions. Here are the solutions, 3 and 4/5. Now what they do not want in this problem is fractions in our final answer. So even though I'm going to start with a fraction, I'm going to end with no fractions, and I'll show you how to do that. So we remember that the format is always x minus and x minus. And all we got to do at this point is enter the two values up here, 3 and 4/5, into what x is minusing. So here we've got the 3, and here we've got the 4/5. Now, like I said, I'm going to keep the fraction, but once I get my quadratic, I'm going to clear those fractions, and we're going to use a principle of equality to do that. But before we get there, let's go ahead and start our distribution. So I have x times x, which is going to be x squared. Then I've got x times a negative 4/5, which is negative 4/5 x. And then we've got this negative 3 distributed to both terms as well. So negative 3 times x is going to be negative 3x. And then negative 3 times negative 4/5. So I'm going to keep this as a fraction and show it as positive 12/5. And yes, this still equals 0. But now, just like we've seen before, we have these two x terms that we now need to combine. So that's negative 4/5 minus 3/5, which would really be negative 15/5. And that ends up being negative 19/5 right there. So we now have x squared minus 19/5 plus 12/5 equals 0. Now, like I said, we're going to clear those fractions. And we're going to do this by applying a principle of equality. So here's the principle of equality we're going to do. Since they're dividing by 5, we're going to multiply the entire left side by 5. But if I do it to one side, I need to do it to the other side. And another way to do this is you could say, well, I'm just going to distribute that or just apply to each individual term. It does not really matter as long as you do it correctly, okay? So I'm going to say take this 5 and multiply it by x squared. That'd be 5x squared. Okay, and here's what happens with our denominators. We got 5 times negative 19/5, which is just negative 19 of those x's. And then, of course, distributing it to the 12/5 would be a positive 12. Now, why does that happen? It's because if you look at the denominators 5 and 5, I know I can multiply these two terms by 5 in order to pretty much inverse the division, and it makes those 5s go away. So that's why we end up with just the numerators in our final answer. However, it also applied to the x squared, and the x squared we could also say, look, it was a 1x, so 5 times 1x squareds would give me 5x squareds. On the right side, of course, we have 0 times 5, which of course is going to be 0 still, and then we can see clearly, hopefully at this point, that we have our final quadratic in standard form without any fractions. Along these lines, because some students were asking in class, well, what if this is a 10 right here? Okay, then you multiply everything by 10. 10 is a multiple of 5, so we're just going to use the higher of those two values to find it. What if it was a 3 and 4? Then it's kind of like a common multiple, the lowest common multiple, though it doesn't have to be the lowest. You'd say, if this was like a 3 and 4, I could say, well, 3 times 4 is 12, then I can multiply everything by 12. Now, that's going to change some of the stuff on the inside, but you'd use a calculator to do that. And in addition to that, the homework assignment that I remember seeing did not actually have anything like that on it. So you should only end up with something like this. And hopefully that's easy enough for now while we try to get used to that until further notice, when maybe they do start changing these into some different values, or where one value is not a multiple of the other one.